Hello students, welcome back. Today we are going to learn about the new topic that is machine learning. So, machine learning can be divided into two broad terms. First one is machine and next one is learning. So, can you tell me some examples of machine that can learn? Okay, let me help you about this. So, it can be a computer. It can be a robot, it can be a biometric machine, or it can be a automatic teller machine. So ATM. Now, what these machines do with learning? So we can say a learning is a next word in the machine learning that has a meaning to learn to do certain tasks. So, if you want to do a task, then you have to learn about it. So, it means a computer can learn to do some certain tasks. Robots can also learn to do some certain tasks. Likewise, biometric machine or ATM machine. So this is not the end of the list of machines that are present in real world. We have so many machines available and they do numerous tasks for us so that we can capable of doing all these work as simple as that. So we can move the computer. So computer can learn how to recognize spoken words. So this is a point about computer. Computer can learn how to recognize spoken words. So this we called as speech recognition system. And what computers learn next is computers can learn how to recognize handwriting. So, if computers is capable of recognize handwriting, then it is a system that is handwriting recognition system. Then, next is robots. What robots learn? So, robots learn to do all the tasks of home like cleaning home or put all the objects at their place like books, shoes, etc. So in this point we are telling about how robots are useful to us. They can do all the tasks what they learn from us. So they learn to do all the tasks of your home. It can be your cleaning, it can be put all the objects at their place, etc. Other examples are robots can learn how to drive on public four-lane highways using vision sensors. So, in this case, robots can also learn how to drive a public four-lane highways. So it means we have some robot cars. So in the case of robot cars, we have no person to drive at all. So we have a robot that can drive on a public four lane highways. Next example is biometric machine. So biometric machine can learn how to authenticate or identify a person through some physical characteristic like fingerprint, face pattern and human voice. So, biometric machine can learn about how to authenticate or how to recognize a person through their physical characteristics. So, a biometric machine can take fingerprint also. It can record your face expressions. It can record your human voice so that they can mark your attendance or anything else. So, it can be used for some useful purpose. Next one is ATM. ATM is an automatic teller machine. So ATM requires a user to pass an identity test before any transaction to be processed. It means if you want to do a transaction at ATM, prove your identity that you are a valid user who uses that particular ATM. So you have a valid credit card or debit card. So it means ATM test your identity. Okay, so from all these examples, we can give a simple definition of machine learning through this slide. So we can have a machine learning is the field of study that gives the computer the ability to learn without being explicitly programmed. So that this definition is given by Arthur Samuel, that is given in 1959. So machine learning is a field of study that gives the computer the ability to learn without being explicitly programmed. So machine learning is what? It is a field of study. Now, in this particular case, we have given various examples. From these examples, we can say that the ATM machine can prove the identity of a person before doing some transaction. So, they are able to learn how to recognize a valid identity. So this is a machine learning technique. Then if we are using a biometric machine or a handwriting speech recognition system, so for that machine has to learn about the patterns human write on the paper. So they have to identify or they have to learn about how human writes, what type of writing they have. So every human has different writings, so it means they are capable of identify those handwritings that are given by a human. So how can they learn about this? So, in this, the main question is how computers learn. So, this is given through this slide how computers learn. So, computer learns similar to man. The answer is this. The computer learns similar to man. The next question that arises here is through this slide, that is, how can we learn? So if computer learns similar to us, then how can we learn? So moving to the next slide, we have an answer here. How can we learn? So if a person named as Cherry want to learn a cycle, so this particular task takes time. So in a real world, if a person wants to learn a bicycle, so this task takes time. First day, Cherry has to learn what, how to hold handles and put one of the foot on the pedals. So this is the first step what Cherry has to learn. Next is they try to make a push on the pedal by maintaining balance and try to place second foot also. So the next step goes here. Then she tried to push a pedal on the right pedal and try to maintain the balance so that she will not fall. Then, on the meantime, she tried to place a second foot also. Now, the first hand goes on. Then we move to the next slide. Then we have a second day. Second day, she tried to maintain balance and kick off paddle so that it can start half. So she tried to do the next step. So it means she tried well, doing and doing again, and she tried to maintain balance and try to kick off all the paddles. Then on the third day, she practiced more and more and more, and after some days doing this, she smoothly drive a bicycle. So, how can we learn? So, just going back to the slide again, we have what we do if a person Cherry want to learn a bicycle. So, learn a bicycle is a task that she has to perform. So, the first day what she do? She do some learning. So, there is a learning in between this process. Then, then second day, on the second day, she tried to maintain balance. So she has to do some efforts again. Then on the third day, she practiced more. On the fourth day, again and again and again. And after some days, she smoothly drive a bicycle. So, what she do? What she has some experience. So if we do our task again and again and again, then we are collecting some experiences. And if we do that particular task for the first time, the performance is not so good. But as we do more and more practice, the performance is going better and better and better. So this is the case with machine learning also. Now there is a definition in the next slide. So let's go into that. A computer program is said to learn from experience, that is E, with respect to some class of task T and performance measure P. If its performance at task in T as measured by P improves with experience E. So, a computer program is said to learn from what? Some experiences. So, experiences are the way she is doing practice. So, it can be a series of actions, or it can be a series of data what they provide to that their her efforts to learn a bicycle. Then she has to perform some task. So task is what? To learn a bicycle. This is a task. Then performance measure P. Performance is when she learned for the first time, the performance is quite poor. But as she goes on and on, then the performance is going better and better and better. So, if we have a computer program like this, in this way also we have a task, we have some experiences or data, and if we perform if we do some performance measure also, in that particular performance we are getting some better results. So this is a definition that is given by Tom Michel in 1998. So task is to play a game, it can be to learn a bicycle. Experience is some data. or we provide some rules or some training data to the computer. So we have to play more and more and more games so that we can provide some training to that machine. And the last one is the performance measure, that is the winning rate. So if we want to play a game and we win again and again and again, so it means our performance is better and better and better. Next, through this slide, so this is the next slide. The next topic is well-defined learning problems. So well-defined learning problem is if a computer program is set to learn from the experience with respect to some class of task T and performance measure, it can be improved with experiences. So this definition is again given by Tom Michel, through which we can define our learning problems. So the first example is, so moving to the next slide, the first example is a checkers learning problem. Checkers learning problem is in this checkers learning problem we have a task T, that is playing checkers. So task is what? Playing checkers. Next is if we want to measure the performance, so performance measure is percentage of games won against opponents. So if we have a percentage of games that we won, so it is a performance measure. And last one is a training experiences, that is playing practice games against itself. So we have some training experiences or training data through which a machine can learn about how to identify the performance measure through this training data. So this is a well defined learning problem. Next one is the handwriting recognition learning problem. So in this case, task T is recognizing and classifying handwritten words within images. So if you are providing numerous alphabets or numbers, that is in the form of handwritten, then computer can identify what the particular number or alphabet is. So it can be learned through some training experiences, that is a database of handwritten words with given classifications. You have to provide some data for which you have to tell that this one is O, this one is 0. So you have to distinguish between O and 0. So learn, you have to give some training to that particular machines. Now a machine can perform according to that particular training experiences. So this is a performance measure, that is percentage of word a machine correctly classified. So this is a well defined learning problem. The third one is a robot driving learning problem. So in this case the task T is driving on public four-lane highways using vision sensors. So in this case, a robot in this a robot can drive on a public four. In this, a robot can drive on a public four-lane highways. And so, what we have to provide to the robot? So what we have to provide to the robot, that is the training experiences. So it means it can be given a sequence of images and steering commands recorded while observing a human driver. So first we will we already have observed a human driver, and through this observation we collect a sequence of images and steering commands, and that is the training data. So through this particular data we train some machine, and on that particular experiences data the machine can perform, and the performance measure is the average distance traveled before an error. So it means we can judge like this also, if a human can drive a same car or a robot can drive a same car, so there is no distinguish between them, so there is no error between them, this is almost same. So we can say a robot can learn a driving. So this is a well-defined learning problems. So this lecture we have learned about what is machine, what is learning, what do you mean by machine learning, what are the well-defined learning problems in case of machine learning, and what are the main factors through which we can define a learning problem as a well-defined learning problem. So, thank you very much. If you have any doubt or any problem, please comment us so that we can be working on that, and we will be very happy to answer you. Thank you very much.